All right, let's take a look here. We're going to finish this off. We're going to look at trig equations with identities. So my first example is going to be, or I should say for problem 1, if it's on a worksheet one day, we'll keep it very simple. Sine theta is cosine theta. So we're going to try this particular problem here, very famous example. Typical example, should probably be in every book. Now, I could have done this in the algebra. I could have said this is like an algebra in the trigonometry, solving trig equations with algebra. But I'm saying here, let's put this under identities. And this is kind of, it could belong there, but it could go to both places. What you want to do here is you're going to divide both sides by cosine theta. Now, what that does for you, algebraically, is that you get now this equation here. You get sine theta over cosine theta will equal 1. You guys okay with that? Now, what's sine theta over cosine theta? This is what I say we can put it either in the algebra category or class of problems, or we can put it in the identity, because sine over cosine, this identity here, okay, we know is actually what? Tangent. Okay, now that's kind of a big deal. So it belongs in both. Now I'm going to remark, some of you guys might say, hey, why don't I just simply, subtract cosine from both sides, like we've been doing, and get sine minus cosine is 0. And then I'll say to you, well, okay, good luck. How do you try to solve for a trig function there? Sine or cosine, you can't do that. So just want to remark, just a quick remark there, that the move here would be simply to divide both sides by this cosine over here, okay? And then we get tangent theta is 1. And that's the whole idea. So now we're going to have to find solutions for tangent theta being, 1. And you guys already know, since this is positive here, since 1 is positive, our quadrant 1 reference angle is one of the solutions. So let me bring in here, and this is kind of tricky. Let's bring in our Cartesian coordinates. Okay, so it's a little tricky, so I'm going to put it over here. And what always kind of happens, good, I'm grateful. I won't go into the details. But here's where we're at, okay? Here's our Cartesian coordinate system, our x and y axis, this plane here. All students take what? Calculus. So like before, we need to find where tangent is really what? Positive here. Is that right? What quadrant is tangent positive? Quadrant 1, quadrant 3. Notice they're opposite. So today, we're going to be a little more efficient. Reference angle, reference angle. So tangent theta being 1 over 1 will give us our quadrant 1 solution, or our reference angle. Okay? All right, there we go. Opposite over adjacent, what's my hypotenuse? And that's square root of 2. So in other words, the reference angle is pi over what? 4. This is a special triangle. So my first solution here, let's go. First angle here, pi over what? 4. Is that right? Okay, how do I get the quadrant 3 opposite solution? Quadrant 3 opposite solution, what do I do? Pi, good, plus pi over 4, good. So you guys also already know the shortcut for doing your arithmetic, take 4 over 4. Always use this denominator, is that right? And you're going to obtain a solution that's going to be 5 pi over what? 4. Okay, my two solutions here. So, since this here is a single angle, theta, single angle. Okay, if you guys remember that, original equation here, what could we say? That our solutions, let's describe the solutions. If they restrict the domain between 0 and 2 pi, you got these two solutions you're looking at right here. Pi over 4 and what? 5 pi over 4. Now, that's not the case if it's multiple angles. You guys have seen that. If it's multiple angles, we have to go through the whole process, right? So it's single angles, that's good. So we could just say, you know, here's our solution, and then some textbooks just, I'm going to start to list it as a solution set. Here's my first solution, pi over 4. Here's the next one, 5 pi over 4. We are done, okay? Now, let's go talk about, you guys should know, by now, we got the general solution. General solution. This is kind of nice. We can say that theta will be take only one of the solutions here. Is that right? You guys know this? Why only one? Take that first quadrant 1 solution. We're going to say pi over 4 now. How do I generate all other solutions in general? What do I add? Right? We're going to get this other solution over here, right? We're going to add a multiple of n pi. There you go. And then that's it. You know, that's it for your general solution. And if you want the sequence version, all you got to do is a little bit of algebra again. So you can say pi over 4 plus 4n pi over 4. And that will give you theta being, we get to factor out the pi over 4 now. We're left with 1 plus 4n. N is an integer. So this will give you every sequence, or I should say every solution. Okay, if they change your what? If they change your interval of allowable answers, meaning if they want this not necessarily over 0 to 2 pi anymore, maybe 0 to 4 pi, 0 to 6 pi, doesn't matter. They could define your restriction any way they want. I want to just give you the general solution here, and you know we've talked already a lot about that. So this is how you handle a tangent situation. Okay, you guys okay with that? Or I should say sine theta is cosine theta. This is our first identity. And then I'm going to say to you what happens now if they give us another example. Let's call this 3. So I'll do the odd sequence here. 1, 3. What if they give us sine 2 theta now is minus cosine what? 2 theta. This is a very similar approach here, right? We're not going to add cosine 2 theta to both sides. What are we going to do? We're going to divide both sides by what? By cosine 2 theta. What that does for us is we get now, let's consider what's sine 2 theta over cosine 2 theta? Tangent 2 theta. And what happens over here? What's cosine 2 theta over cosine 2 theta? This portion here is 1, is that right? So tangent 2 theta here is negative what? 1. That's right. Okay, now let's try to bring in our graph. Got this in the corner. Good, we're having a good day. Tangent here, 2 theta is what? Isn't that negative? So if we're going to consider our reference, we need to consider where tangent 2 theta is positive 1 over 1. So our right triangle now will look like this. Two theta, 1 over 1. You already know this is square root of 2. So we know the following here. Let's go back a few seconds. I think we skipped something. Where's tangent negative? Quadrant what? Quadrant 2. You know this. And quadrant what? 4. Good. So let's consider my reference angle. My what? Reference angle. This reference angle, which is not a solution, we should say, what's the deal there? We're saying 2 theta will be what? Pi over 4. So my reference angle here is pi over 4. Okay? It's not a solution though. So let me erase this here and say this reference again is pi over 4. Your reference over here again is what?
Pi over 4.
Pi over 4. Let's find the angle. Quadrant 2. Pi minus pi over 4. Is that right? What do you guys know? What is that? Good. And over here you get 2 pi minus what? Pi over 4. Quadrant 4 solution. What does that give you? What do you guys think? What does that give you? Is that 5 pi or is that 7 pi over 4? I think that's 7 pi over 4. Is that right? All right. So let's be awake with this. What we're looking at here, we try to describe maybe a general solution here so we can generate some sequences possibly. I don't think we'll do that today. I think we've done enough. I think you guys seen the point. But if I want to find a general solution, let's get rid of the reference. We don't need it anymore. What would we say? Let's list one solution. What's our solution? 3 pi over 4. And then I'm going to add now what? Go back. There's that solution we just listed. How do I get the alternate quadrant solution? You're going to add always a multiple of what? N pi. And that will give us this alternate solution. And we'll do this all day long. Add a multiple of n pi, subtract n pi, add 2 pi, subtract 3 pi, whatever. We get all those coterminal solutions. So we've seen this over and over again. Now today, like I said, I'm just going to give what? The general what? Solution. Because I believe there's been enough examples to show you how to find the sequence and how to generate the what? Sequence. Meaning, how do I find the general form for the sequence version to generate the sequence of solutions? I've probably done about 20 examples. So at this point, what are we going to do? We're going to just leave it like this. And we're going to move on to other what? To other examples. Okay, you guys okay with that? Yeah.
Why was it negative again?
Why was it negative?
Yeah.
Okay. Originally, what was given here.
Okay.
Yeah, exactly. That's fine. The negative is there. Good. Yes?
So what happens to the double angle?
Oh! Glad you're awake. Good job. Good man. Thank you for waking me up. This is old man syndrome, so thank you. Nothing happened to it. It's there. We're not done. Okay? Thank you. I'm so glad you guys are here. Thank you. Okay, let's divide both sides now by what? By 2. Okay. Cancel. And there we go. Theta becomes 3 pi over 4. Don't forget divided by 2 plus n pi divided by 2. We were not done. Theta will be 3 pi over what? 8 plus n pi over 2. Yeah. Okay. Now we're good. General solution. And like I said, you guys can actually generate, if you like, the sequence version, blah, blah, blah. Now this is good for, you use this version for any restricted domain. So we're going to assume here theta is over all real numbers, or there's no restriction. This is just the general solution. So that was number, what? 3. Okay. And number 5. So let's kind of see how we can use other identities here. So I got here, you got a cosine double theta equals cosine of single theta. Okay, now at first glance, you say, wait a minute, is there a typo? Because maybe you say, I want, you got a double theta mixed, you got a double multiple angle double theta mixed with a single angle. So, first glance, we think there's an issue. There's no typo. Now, remember I said to you guys you're going to have to bring out some identities. See this cosine double theta? We could use 2 cosine squared theta minus 1. Does anybody recall? Cosine squared theta, wasn't this 1/2 times 1 plus cosine double theta? Is that true? So I want to discuss here with you guys where this actually came from. In other words, you can say, why do you replace that with 2 cosine squared theta minus 1? Where did that come from? Well, it came from your reducing power identity, right? Remember this? You had that in the test. Cosine squared theta is 1/2 1 plus cosine 2 theta. Well, I'll just say use some algebra now and simply solve for what? For cosine 2 theta now. Now, if you do, notice you're going to multiply both sides by 2, so you get 2 cosine squared theta. That removes our fraction 1/2, and it's now 1 plus cosine double theta, just by doing what? Multiplying the left side by 2 and your right side by what? 2. Just point out that detail. Okay? You guys got that? Multiply both sides by 2. Now, I'm going to erase this because it's distracting to me. Okay. How do I solve for cosine 2 theta now? Remember, I'm solving for this. Yesterday, I talked a little bit about what I like, which is called translation. So we'll see that 2 cosine squared theta minus 1 is, in fact, cosine what? 2 theta. So wherever I see a cosine 2 theta, the original problem, I can always replace it with 2 cosine squared theta minus 1. That's where we're at. So bring everything down. 2 cosine squared theta minus 1. Okay, put that in parentheses, I guess, is cosine what? Theta. Anybody have any questions on why I replaced that cosine 2 theta with this identity? Okay, what do you guys notice about my equation now? What is this? Single angle. Single angle. Is that true? And that's the idea. And, this is algebra, so I'm going to say to you again, translate your cosine theta here. Okay? And you get 2 cosine squared theta minus cosine theta minus 1 is 0. So remember when we worked with the algebra the other day, yesterday, the other day, who knows? If I let t be cosine theta, what kind of equation does that give me now? Don't I get what? 2t squared minus t minus 1 is 0. I just have to remember some algebra. I got to remember how to factor. Hopefully this is factorable. Anybody know, is this factorable? Yep, I think that's minus 1 and plus 1. Is that true? So let's see what this gives us. 2t minus 1 is 0, or I should say, let's really be clear here. Since t is cosine theta, don't we have 2 cosine theta minus 1 equals 0, and then cosine theta plus 1 equals 0. Is that true? Because that's what t is. So we did a t substitution. So I'm going to solve for cosine theta now, right? We're going to solve this for cosine theta for both equations. So this gives me 2 cosine theta equals positive 1 by translating the 1, and it gives me cosine theta equals negative 1. Divide both sides here by 2, and I get cosine theta being 1/2. Here's 2 equations I have to consider for theta now, right? Cosine theta is positive 1/2, and then cosine theta is what? Negative 1. Okay, yes?
I think you have the signs mixed It's on the products. It should be 2t plus 1. T minus.
Holy moly, okay. Easy to fix. Plus, and then this is what? Minus. Ooh, I actually thought it was a good day. Maybe not so. Let's erase this here. Okay, so when I translate, this now becomes -1, right? So we get this good. So -1/2, okay. And we translate here, this is now going to be what? +1. Okay, good. Whew. All right, here we go. This is where we're at. So I'll say at this point, I think you guys should really know how to do things. Is that true? At this point, I would say let's bring in our graph and let's start to look at this. There's two things to consider. Where is cosine actually negative? What quadrants? Is that 2? Here we go. Quadrant 2, quadrant 3. Is that right? So I'm going to focus on my cosine of -1/2. I need a reference angle. My reference angle here, cosine theta being actually +1/2. Adjacent hypotenuse. Let's hope that we get this right. I don't make a mistake here now. Again, adjacent over hypotenuse. I think I'm okay. What's the opposite side? That's square root of 3? What kind of triangle is this? All right, what is theta? What's my reference going to be? It looks like it's 60 degrees. So what do we say? pi/3. There we go. There's my reference angle. So pi minus pi/3 because, let's say, isn't that going to be my, remember this? There's my reference angle. Here's my reference angle. And what's the other solution here? This will be pi what? Plus pi/3. So what are the two solutions here for cosine being actually not positive but negative right here? -1/2. Yeah, what do we get? Theta would be 2 pi over 3 in quadrant 2. Is that right? What's theta in quadrant 3? 4 pi/3. Alrighty. Okay. I'm just going to keep this up. So far, I have a quadrant 3 solution and a quadrant 2 solution. Now let's consider cosine theta being 1. So let's ask you guys this question. In the interval from 0, right, to 2 pi, really over this 4-quadrant scenario, where is cosine theta +1? Right, let's ask you, where's cosine theta 1? In this particular what? Interval. Notice I'm not including to what? Pi. I don't know if that means anything. So what do you guys know about theta? What does theta have to be? 0? Is that true? Is theta 0? Cosine 0 is 1? I think so. Is there any other angles for theta where cosine is 1? Huh? You'll tell me, hey, Mr. Judge, it happens at 2 pi because when you sketch your cosine curve, right? I don't know if I want to sketch it. You're going to say to me, oh, you know what? When I sketch that cosine curve, you guys have that already. I get 2 pi. Cosine 2 pi is also 1. But notice we're not including 2 pi in our restricted domain. So that goes what? Away. So long story short, cosine is what? 0. 0 is a solution here. So where is 0 here on my graph? This is where theta, or cosine, this would say this is where theta is 0, right? So I'm going to put another solution here for you guys. All these values are solutions for what? This particular trig equation, number 5. And if I had to say, what is your solution set in our restricted domain here? Final answer. Well, you'd say happens at 0, happens at 2 pi over 3, and it happens at 4 pi over 3. And again, this is all over this here. Go back here. The interval from 0 to 2 pi, not including 2 pi. So there you go. Nevertheless, we said if they ask us a general solution, maybe they don't include any restriction. Good. Let's provide a general solution. Tell me, what would you guys do in this case? You had all this experience. Take a look at this picture. Take a look at all this information. Tell me how you would describe the general solution. What would your approach be? Start with what?
0.
Good. And what do you add? Anybody want to tell me what you add? You started with this angle, theta 0. How do we get every coterminal solution to that? 2n pi. Thank you. Don't do the n pi because you don't have opposite kind of quadrants. Is that right? Good job. There you guys go. And let's go get the next value here. Theta is, what are we going to say? 2 pi over 3. Okay. And what are you guys going to add for this angle to get every coterminal solution? What are you going to add now? 2n pi again. Okay. All right, that's really good. And then, we need more space since we're having fractions. We're going to write 4 pi over 3. What are you guys going to add now? 2 and what? Pi. There you go. Here's your general solution. Okay. Now, yes, 0 plus 2 and pi. You can also say, hey, is that just 2 and pi? The answer is yes. This will generate every coterminal solution to that 0-degree angle. Notice 2 pi is there, and and so on and so forth. So I'm not going to go through sequences. I'm just going to give you your general solutions here. And, at this point, that's good enough. What do you guys think? Doesn't a picture tell 1,000 words here? Right? If you look at all these angles, notice you do not have coterminal solutions, coterminal angles, where you have that n pi multiple. Okay, they're not in opposite kind of quadrants. They're not opposite situations. They don't differ by 180. So that was number what? 5. Let's kind of take a look at number 7. And let's see if there's any kind of algebra now I can do here with this one. So we have 4 sine theta cosine theta is the square root of 3. Now, before you actually subtract the square root of 3 from both sides, right, and say, oh, I want to translate this, that's going to give you a problem. What am I talking about? You guys know what I'm saying? You say, I want 4 sine theta cosine theta minus the square root of 3 is 0. Don't even do this. How could you use the zero product rule here? You can't. You can't factor. You can't distribute. Okay? So that's not the move. And you might say to me, since that's not the move, what am I going to do? Well, what's the title of this lecture? What's the title of this video, whatever you want to call it, this resource? It's solving trig equations by using what? Identities. We've got to use an identity. Now, I want to mention this to you guys. Here's one identity that pops up a lot, and it popped up here. Like the first identity we use, that happens a lot. Do you guys know what is sine Remember this double angle? What's sine 2 theta? Remember that double angle identity? 2 sine theta, what? Cosine theta. If you're going to get a tattoo, this is a good one. Because it shows up a lot in a lot of courses, this double angle, sine 2 theta. Like cosine 2 theta shows up too, and there's an identity there, right? So these double angles show up. I'm going to say to you, okay, then what does that mean? That means that if I divide both sides by 2, that sine 2 theta divided by that 2 is sine theta cosine theta. So wherever I see now a sine theta cosine theta, right here, sine theta cosine theta, what could I replace that sine theta cosine theta with? Anybody want to tell me? I'll highlight in red. Sine 2 theta over 2. So your equation will become 4 not times sine theta cosine theta, but 4 times what? Sine 2 theta over 2. And that's going to equal square root of 3. Just do some algebra and simplify. 4 divided by 2, you guys know is actually what? 2. So you have 2 sine 2 theta is the square root of 3. And now you can divide both sides now by that 2. And you obtain here your, bless you, you obtain your sine 2 theta, which is the square root of 3 over what? 2. There's your equation you're going to have to solve. Okay, you guys okay with that? Now, I make the claim, at this point, you guys really should know how to do everything. You really should know how to finish this stuff off. We've seen this over and over again. So, I mean, I have my reservations about finishing it, but let's do this. Okay, let's do this kind of quickly, I guess, because you guys should be really good with this by now. Okay. Let me do this here. Yeah, I wonder when I was going to do this. This is kind of what I kind of experience whenever you import these pictures here. Just, you know, Apple, if you're listening, fix this problem, okay? You can't really exactly place it where you want. You got to play with it a little bit. So there's an issue. Anyway, this value here is what? Positive. Is that right? Okay. So since it's positive, let's stop and think about this. Sine 2 theta, where's our solutions going to be? Where is sine positive? 1 and 2. So I'm going to have an angle here and an angle here. Yes, we need a what? Reference. Yes, we need a reference. Let's wake up and remember, this is a double angle solution, so let's not forget that like we did prior, okay? So you guys can remind me because, you know, I'm still asleep. All right, let's consider this reference here. Let's find that reference angle. Triangle. Yes, that's a double angle. Definition of sine, what is this? Isn't that what? Opposite over hypotenuse. What's my adjacent side? Well, looks like it's 1. Okay, does anybody want to tell me what 2 theta has to be then? Isn't 2 theta 30 degrees? Isn't that a special triangle? Is it 2? No, what's 2 theta? 60 degrees. Look at that. Here's my equilateral triangle. Okay, pi over 3. Good. Okay, here's my reference. So this first solution, pi over 3. Let's go back. Pi over 3. What's the quadrant 2 solution? Pi minus what? Good. What's the solution? 2 pi over 3. Good. Here are my solutions. Okay. We're going to get the general solution here. It's a multiple angle situation. Always wise, get your general solution. Then you could get the sequence, and you could generate anything depending on what they give you, what interval they give. General solution. All right. Not theta, but 2 theta. What's my first solution? Pi over 3. What do I add? 2n pi or n pi? Good. 2n pi. Because this angle, we don't have opposite what? Opposite angle solutions. So, gone. Good. The next one. Here we go. 2 theta now becomes, what's the other solution? 2 pi over 3 plus, what do we do? 2n pi now. So don't forget, the whole point was to solve for theta, not double theta. So we're awake now. Get rid of the 2's. Let's see what happens for theta. Let's do the algebra. Theta becomes pi over what? 6. Good. Plus n pi. Theta becomes 2 pi over what? 6 plus n pi. Isn't that pi over 3?
Yeah.
So just be careful. Just simplify your fraction. Here's your general solution. Okay, you can create the sequence if you like. Create the sequence, do a little bit of algebra, create the sequence, and then if they ask you any restricted domain questions, you just check that sequence solutions and see which ones are there, which ones are not. Just like we've been doing. You got a lot of examples of that. So today, like I said, I want to go through this without doing that, so you could get more examples in. Okay, that's another identity. What number are we at now? What is this? If this ever becomes a worksheet, which it probably will, is this 9? Is that number 9? Okay, let's check here. Number 9. How about if we take?
We're actually on 8, number 8.
Is it 8? I thought I was going by odds. Please tell me. Please tell me I didn't make that mistake. 7. And this one's what? I thought I was doing odds. What is this? 5. Yes. You would be right. If it were going in order.
Incremented by 1, okay.
Yeah, I'm going to make some worksheet.
by all.
I'm going to torture some trig students next semester. I'm going to make a worksheet. They got to solve all these. And they'll have solutions that are just the odds, but not the evens. And they got to earn those even solutions. So, okay, so that's why I'm doing this way. I'm thinking ahead, multitasking. Cosine squared theta minus 3 sine theta is what? Is 1. They want us to solve for theta. Okay. Now remember here, we're going to use another identity here. Let me remark here. There's various identities for cosine squared theta, but if you read this equation here, this is written in terms of what? Sine theta. Is that right? I know I erased it, but let's put it back. We've got sine theta. All right. I'm going to do the following. I'm going to replace my cosine squared theta with, what do I do? 1 minus sine squared theta. A Pythagorean identity. Now, you might say, why is that? So let's go back and recall that sine squared theta plus cosine squared theta is 1. I can solve for cosine squared theta. I can solve for that by subtracting my sine squared theta from both sides. So you guys should recall that this now gives me cosine squared theta 1 minus what? Sine squared theta. So wherever I see now, let's go back here, a 1 minus sine squared theta, or I should say, let's take it back. Wherever I see a cosine squared theta, right up in here, I can replace that cosine squared theta with my 1 minus sine squared theta, and that's what I'm just saying, replace it. And when you do, you get, what do you get? 1 minus sine squared theta minus 3 sine theta equals 1. So what you guys can see, this is starting to resemble a quadratic. It's a quadratic in terms of sine theta, meaning that's your base. And that's the idea. It's actually a quadratic. Now, doing a little bit of algebra, meaning if I subtract 1 from both sides, notice this algebraically. I have minus sine squared theta minus 3 sine theta now. That equals 0. Because the 1's canceled. Okay, subtracting 1 from both sides. If I multiply everything by negative 1, which I like to do, I get sine squared theta plus 3 sine theta now will be 0. Now, you can use t if you like, and you can say, you know, what if I said t now was sine theta? I could do a substitution. That will give me t squared plus 3t is 0. And yeah, I factor and I get t plus 3 is 0. But, you know, my algebra skills, I've had a lot of practice. Sometimes I just simply rather say, you know what, I'm going to directly factor out a sine. And I get now sine theta plus 3, that's 0. Can I do that? I can do that. I don't have to do a t sub. So I'll do that. Now this puts me in that position again where I have two solutions, where I have my zero product rule from beginning algebra. Sine theta is 0, and then sine theta plus 3 is what? Is 0. Okay, you guys with me on this? Well, I got news for you. I know when sine theta is 0, and if I consider again my restricted domain. Okay? Sine theta is 0 when theta is what values? 0 and one more. Okay, let's draw the picture. Now let's do it this way. How's that? I know I went here. There we go. Not the best picture, not to scale really. Here's one. I'm going to start it to do. I'm going to do like 2 spaces equals 1, but nah, let's be. We're okay with that. Okay. This is my theta, right? Here's my sine curve. If I want, technically, so my colleagues don't yell at me, I'll put arrows because these are lines. Okay. 0 here and here. This is over the interval. If you guys remember, what's this? Pi. What's this? 2 pi. This will be pi over 2. This will be 3 pi over 2. I don't have to label them, but they're there. Undo. What's the point I'm making? We're assigned 0. 0 pi, and you go, oh yes, and also 2 pi, and I'll say get rid of the 2 pi. Anybody know why?
Because it's in the restricted domain.
Your restricted domain doesn't include 2 pi. So get rid of that answer. Okay, good. And then I'm going to say to you guys, solve this. We're not done. Solve this equation for sine. So you say, okay, sine theta then is -3. Now I'm really happy that I actually drew this picture of sine. Does anybody know why? Let me extend this axis. There's a very important detail we want to talk about here. We're saying sine theta is -3. So for what theta is sine theta -3? Let's check. This is where -2 would be. This is where -3 would be. Does my sine curve ever touch -3? So sine is actually never what? I'm going to write that down. I'm going to say this. This never what? This never happens. Sine is never -3. What does that mean? It means throw out this information. It's not valid. We don't consider that. Sine's never -3. So the moral of the story will be here, if they want a particular solution in the interval of 0 to 2 pi, If you're looking back at the book, you'll see set notation. Theta is 0, theta is pi, and you're done. This is your answer for your restricted domain of 0 to 2 pi. And if you're awake, let's say this. What will your general solution look like? Anybody know what the general solution would look like? I have a value there, and to the left forever. Does everybody happen to know what these values will be? General solution. Anybody happen to know? What am I going to write down? Let's write it down here. Your general solution here, we'll change it back. Theta being what? What would you guys say? N pi, n is a what? Integer. Is that true? N pi. So I wanted to go over this kind of problem with you, show you that sometimes it comes up where you may have algebraically, sine, cosine, whatever, it's not even possible. So you just throw that information out. Okay, good job. That's number, if we're odd, 9. That takes us now to what? 11. All right, let's see. Let's do a similar question. Cosine 2 theta is 3 cosine theta plus 1. It's a little too close. Cosine 2 theta is 3 cosine theta plus 1. Okay, what do you guys want to replace cosine 2 theta with? What do you guys think? What do we use earlier? Can I replace that with? What do we replace that with?
1 minus 2.
2 cosine square theta minus 1. Good job. Okay. 2 cosine square theta minus 1 is 3 cosine theta plus 1. Okay, let's do some algebra. I'm going to translate my terms. Get them all on one side. Set that equal to 0 on the right side. 2 cosine squared theta minus 3 cosine of theta. There's already a minus 1, and now there's another minus 1, and that is 0. I get 2 cosine squared theta minus 3 cosine theta minus 2 is 0. Okay, you guys okay with this? Now it's up to you. You can let t be cosine again and say t will be cosine theta. Now that gives you again 2t squared minus 3t minus 2 becomes 0. Now let's hope we can factor correctly. 2t, t is 0. This is 2, it's going to be negative, and this is 1, and it's going to be positive. Double check to see if I'm able to factor now. 2t squared, negative 2, negative 4t plus t. Looks like we're good. I'll do my algebra a little differently. I'll solve this equation a little differently. Okay? This means 2t is minus 1, or t is what? Negative 1/2. This means t is what? 2. Go back. What is t? It's cosine. So we have cosine of theta being negative 1/2. We got cosine of theta being 2. Anybody want to know what I want to do with this last version here? I'm going to throw that out. Anybody know why I throw that out? This never what happens. Cosine is never bigger than 1. Cosine can't be 2. Doesn't matter what angle. Throw that out. That leaves you just with cosine theta being minus 1/2. And we'll try to do this. Remember, this is a single angle, and that's good. So we'll try to do this somewhat, quickly, so we could get some more in here. Let's bring our quadrant in. Okay. Let's try to make that a little bigger. Good. We got it. Okay. Where is cosine negative? Quadrant 2, quadrant 3. We still need a reference angle, though. You guys already know my reference angle will be where cosine of theta is actually positive 1/2. Adjacent, hypotenuse. What's the opposite side? What's the opposite side? Square root of 3? Is that true? Is that cosine being 1/2? Okay, we need the reference angle. What does theta have to be then? Anybody recognize this triangle? Yeah, it's pi over what? 3. It's another, again, you've seen this over and over again. My reference angle is pi over 3. Now, what that means, we're doing it a little quick, which is good. Pi minus the reference and pi plus the reference. Is that right? Is that 2 pi over 3 for one solution? What's the other one? Is that 4 pi over 3? Double check. I'm not awake and I'm moving fast. For these angles, cosine is negative 1/2. Okay, we're looking at this angle here. Oops. Undo. These two angles. Okay. Alrighty, what do we want to remember? Something, this never happens, this is always happens. Okay, let's describe our solutions. Okay, our solutions are going to be here, let's put in black, particular solutions here. This is 2 pi over 3 and 4 pi over 3. And this is for a restricted domain from 0 to what? 2 pi. Okay? Looking back at the book, here's what we see. General solution now. You guys already know. What do we do? Theta being 2 pi over 3. Theta being 4 pi over 3. What do we add? Multiple of n pi or 2n pi? Let's look at our picture. This is not even a solution. It's a reference angle. What do we add? 2n pi. Good. So you could generate your sequence if you like, if they give you another sort of restriction. But nevertheless, here's where we're at. So this was number what? 11? All right, let's see if we can keep going. Notice when I don't have to generate all those, it goes a lot faster, which is good. We're at number 13. Let me give you a good one here. Let me try this out. Sine 2 theta, okay, equals 2 tangent what? 2 theta. Now here's what I'm going to do, okay? I know I have sine here, right? You see sine 2 theta? And I also know something else. That tangent theta can be described as sine 2 theta over what? Cosine 2 theta. You okay with this? Notice I have a numerator for sine 2 theta. I'm using that identity. So sine 2 theta becomes 2 sine 2 theta over cosine 2 theta. You with me on this? What should I do now? If we multiply both sides by cosine 2 theta, don't I get cosine 2 theta canceling out here? So I'll get cosine 2 theta times sine 2 theta. It's actually 2 now sine 2 theta. So let's do some algebra. Let's bring out this 2 sine 2 theta to the other side to make 0 on the right side. And I'm going to rearrange here my sine 2 theta. You'll see what I'm talking about. Sine 2 theta, now cosine what? 2 theta. Minus 2 sine 2 theta, and that equals 0. Anybody want to suggest something? Sine 2 theta, sine 2 theta. What should I do? What do you guys think? Algebraically, what should I do? Let's give you a hint. Factor. What are you going to factor? Sine 2 theta times cosine what? 2 theta minus 2, and then this equals what? 0. Take a look at the algebra here. Okay, this is identities with algebra. And so now algebraically, you get to use the zero product rule. Remember this? We know sine 2 theta is 0. We also know cosine 2 theta minus 2 is 0. Okay? This is already solved. The sine 2 theta equals 0 is already solved. The cosine, though, is not. So we're going to have to add 2 to both sides, maybe, or translate. Cosine 2 theta now is 2. Does anybody want to tell me something about this situation again? This what? Never happens. Cosine of any angle, doesn't matter what it is never 2. Never what? Happens. Throw this portion out. Now, let's see if you're really awake here. Sine 2 theta is 0. What does that actually mean here again? Go back. That meant 2 theta. 2 theta was what two answers? Meant 2, well, we'll say 2 theta is 0. Let's start with that. 2 theta was 0, and then 2 theta was, what was the other answer? Was it pi? Okay. And then generally speaking, in general, what do we say about 2 theta then? 2 theta was what? N pi. Is that true? So go back to the last example and put this idea together. 2 theta is 0, 2 theta is pi. Generally speaking, 2 theta is really an integer multiple of pi, n pi. Now, that's just 2 theta. Divide both sides now by what? By 2. And then your theta is going to be n pi over 2 in general. So here's our general solution. And, you know, you could generate now solutions over any particular interval. But I wanted to actually show you this question here, okay? You got some algebra here. And then finally, I'm going to sneak one in on you guys. I apologize. Let's try another. Are we up to 15? Since we're using identities and we're using algebra. This one possibly could be placed into in both categories again. So I want to, I'm going to keep you a little bit here, and I want you guys to notice something here. Does anybody see anything special about this problem here? What is this? You guys know what this is? Let me do this. Let me give you a hint. What if they gave you, what if I said t was what? Cosine theta. I said s was sine theta. Let's go back to beginning algebra. What if I told you x is cosine theta, and y is sine theta. What are you guys really looking at? Isn't this really going to be what? X squared minus y squared is what? 0. Anybody know how to solve that kind of equation? What's the word now? You factor. Isn't this a special factor? This is the difference of what? Perfect what? Squares. So to remind you, this is x plus y. This is x minus y is 0. Okay, you okay with that? And that's to suggest to you that cosine theta plus sine theta times cosine theta minus sine theta, that equals what? 0. Now, using the zero product rule, we say cosine theta plus sine theta is 0. We also say cosine theta minus sine theta is 0 as well. Anybody know where I'm going with this? Translate my terms. If you want, translate, keep your sign there. Translate cosine here. Translate cosine here. Okay? This gives you sine theta is minus cosine theta. This gives you minus sine theta is minus cosine theta. What do you guys want to do now? What did you guys see earlier today? We're starting this, or we're ending this the way we started. Divide both sides by what? By cosine theta. The second one, make it minus cosine theta. Here's the point. Do you recognize sine theta over cosine theta? Tangent theta. What happens here? -1, good. What's this sine over cosine? You have two negative angles here, or two negative signs. Negative over negative makes this a, I get tangent theta is, again, negative over negative, cosine over cosine. Isn't that 1? So ladies and gentlemen, we're back where we started. In other words, and I'll switch the order, tangent theta is +1, and tangent theta is what? -1. Do you really need me to bring in the graph? Okay, maybe. What do I mean? For the positive solutions, right? Bless you. Where is tangent positive? Quadrant 1, quadrant what? 3. And I'll change this to green. Where is tangent negative? Quadrant 2, quadrant 4. Tangent theta being 1, don't I need a reference angle here? Reference angle here? Reference angle and what? Reference angle? Who can tell me? What is the reference angle? What is theta here? For tangent theta being +1/1, theta is pi over 4. So this is pi over 4, meaning pi over 4 is one solution. What about quadrant 3? What is this? Pi plus what? Pi over 4. We didn't do this here. My reference. What does that give me for the positive tangents? 5 pi over 4. Good. My two solutions. That's for tangents +1. And in green. In green here, pi minus pi over 4. What does this give you?
3 pi over 4.
That's right. And then 2 pi minus pi over 4. What does that give you?
7 pi over 4.
Good job. And then you look in back of the book and they go, We want solutions over the interval from 0 to what? 2 pi. What are those solutions? You're looking at it right here. What is it? Pi over 4. What comes next? 3 pi over 4. And then 5 pi over 4. And then 7 pi over 4. This is your what? Solution that are particular in this picture. Almost there. Almost there. This is only for the A students. General what? General solution. Theta is pi over 4. I'll give you a hint. Theta is 3 pi over 4. Almost there. If you could tell me what's going on, right? What did I do? Then you could leave. I took this solution, and I took what? This solution. I'm going to generate every solution over all real numbers, and then potentially create a sequence, whatever. What do I add? Good job. N pi. I get every coterminal solution because these solutions are in opposite quadrants. They differ by what? 180. Outstanding. Good for you guys.